Good day, everyone. I am Rohalda Q. Calias. Today, I will be the first reporter in Chapter 9, which is improving a classroom based assessment test. By the time you reach Chapter 9, it is assumed that you have known how to plan a classroom test, so by specifying the purpose for constructing it, the instructional outcomes to be assessed, preparing a test blueprint to guide the construction process. Next is the techniques and strategies for selecting and constructing different item formats to match the intended instructional outcomes take up the second phase of the test development process, which is the content of the preceding and improving the items, which is the third phase of the process. Popham 2011 suggests two approaches to undertake item improvement: the judgmental approach and the empirical approach. So let's go to first approach, which is judgmental item improvement. This approach basically makes use of human judgment in reviewing the items. The judges here are the teachers themselves who know exactly what the test is for, the instructional outcomes to be assessed, and the item's level of difficulty appropriate to his or her class. The expert classroom assessors who are familiar with the curriculum standards for the target grade level, the subject matter content, and the ability of the learners and the students themselves who can perceive difficulties based on their past experiences. So let's go to teachers' own review. It is always advisable for teachers to take a second look and the assessment tools he or she has developed for a specific purpose. To presume perfection in the test right away after its construction may lead to failure to detect shortcomings of the test. In exercising judgment, here are five suggestions given by Popham 2011. So, the first suggestion is adherence to item specific guidelines and general item writing commandments. If the teacher has provided specific guidelines in writing various forms of objective test items and more general guidelines applicable in all item formats. For example, avoiding ambiguity and avoiding irrelevant thinking skills. These guidelines should be used by the teacher to ensure that the good test items have been planned and written particularly in their alignment to intended instructional outcomes. Second suggestion is contribution to score-based inference. So, the teacher examines if the expected scores generated by the test can contribute to making valid inference about the learners. Can the score reveal of the amount of learning achieved or show what have been mastered? Can the score infer the student's capability to move to the next instructional level, or rather the scores obtained to not make any difference at all in describing or differentiating various abilities? So, the third suggestion is accuracy of content. This review should especially be considered when tests have been developed after a certain period of time. Changes that may occur due to new discoveries or developments can redefine the test content of a summative test. If this happens, the items or the key to correction may have to be revisited. So, the fourth suggestion is absence of content gaps. This review criterion is especially useful in strengthening the score-based inference capability of the test if the current tool misses out an important content now prescribed by a new curriculum standard. The score will likely not give an accurate description of what is expected to be assessed. The teacher always ensures that the assessment tool matches what is currently required to be learned. This is a way to check on the content validity of the test. The last suggestion is fairness. The decision on item writing guidelines always give warning on unintentionally favoring the uninformed students obtain high scores. These are due inadvertent grammatical issues or clues, unattractive distractors, ambiguous problems, and messy test instructions. Sometimes unfairness can happen because of due advantage received by a particular group, like those seated in front of the classroom or those coming from a particular socioeconomic level. Getting rid of faculty and biased items and writing clear instructions definitely add to the fairness of the test. So let's move to peer review. So there are schools that encourage peer or collegial review of assessment instruments among themselves. Time is provided for this activity and it has almost always yielded good results for improving test and performance based assessment tasks. During this teachers day or triad session, those teaching the same subject area can openly review together the classroom test and task they have devised against some consensual criteria. The suggestions given by the test experts can actually be used collegially as basis for a review checklist. So, this would be the review checklist. A. Do the items follow the specific and general guidelines in writing items, especially on being aligned to instructional objectives, making the problem clear and ambiguous, providing plausible options, avoiding unintentional clues, or having only one correct answer? B. Are the items free from inaccurate content? C. Are the items free from obsolete content? D. Are the test instructions clearly written for students to follow? E. Is the level of difficulty of the test appropriate to level of learners? F. Is the test fair to all kinds of students? So, let's move to student review. Engagement of students in reviewing items has become a laudable practice for improving classroom tests. The judgment is based on the student's experience in taking the test, their impression and reactions during the testing event. The process can be efficiently carried out through the use of a review questionnaire. Popham 2011 illustrates a sample questionnaire as shown in. So, ginagamit ang mga estudyante bilang tagapagbigay ng feedback para mapaganda ang test. Ang kanilang reaksyon at opinyon ay mahalaga para makita kung alin sa mga tanong ang dapat baguhin o linawin. So, sa Table 9.1, it is better to conduct the review activity a day after taking the tests so the students still remember the experience when they see a blank copy of the test. So, item improvement questionnaire for students. If any of the items seem confusing, which one were they? Did any items have more than one correct answer? If so, which ones? Did any items have no correct answers? If so, which ones? Were the words in any items that confused you? If so, which ones? Were the directions for the test or for particular subsections unclear? If so, which ones? So, another technique of eliciting student judgment for item improvement is by going over the test with his or her students before the results are shown. Nagugustuhan ito ng mga estudyante dahil nabibigyan sila ng pagkakataon na magbigay ng feedback sa mga sagot nila habang dinadaanan ang bawat tanong. Tinatanong sila ng sagot at kung mahigit sa isang posibleng tamang sagot, gumagawa ng tala ang guro para baguhin ang item. Dapat dumaan ang guro at estudyante sa mga tanong bago lumabas ang resulta para makita kung may kalabuan o mali at baguhin ito kung kinakailangan. So, let's move to empirically based procedures. So, item improvement using empirically based method is aimed at improving the quality of an item using students' response to the test. So, test developers refer to this technical process as item analysis as it utilizes data obtained separately for each item. An item is considered good when its quality indices, difficulty index, and discrimination index meet certain characteristics. Ang item analysis ay isang technical na proseso na ginagamit ng mga gumagawa ng pagsusulit para suriin ang kalidad ng bawat tanong sa test. Tinitingnan nila ang datos mula sa mga sagot ng estudyante para sa bawat item. Isang tanong ay tinuturing na maganda o maayos kung pumapasa ito sa dalawang mahalagang sukatan. Una ay difficulty index, antas ng kahirapan o gaano kadali o kahirap ang isang tanong. Kung halos lahat ng estudyante na nakasagot ng tama, masyadong madali ang tanong. Kung halos lahat naman ay mali, masyadong mahirap. Dapat sakto lang para masukat talaga ang kaalaman. Discrimination Index, kakayahang mag-iba ng antas ng estudyante. Sinusukat kung ang tanong ba ay nakakapagpakita ng pagkakaiba sa pagitan ng magagaling na estudyante at sa hindi masyadong nakakaunawa. Kung ang mahusay na estudyante lang ang nakakasagot ng tama at karamihan sa hindi masyado ang mali, ibig sabihin maganda ang tanong. So, for a norm reference test, the two indices are related since the level of difficulty of an item contribute to its discrimination. Sa norm reference test, or pagsusulit na ang layunin ay ikumpara ang estudyante sa isa't isa, magkaugnay ang difficulty index or sukat ng kahirapan ng tanong. At ang discrimination index, sukat kung kaya bang paghiwalayin ng tanong ang magaling na estudyante at yung hindi masyado. So, the difficulty index, however, takes a different meaning when used in the context of criterion reference interpretation or testing for mastery. An item with a high difficulty index will be considered as an easy item and therefore weak item, but rather an easy item that failed most of learners to perform the expected outcome. It therefore becomes an evidence of mastery. Particularly for objective tests, the responses are binary in form, right or wrong translated into numerical figures as 1 and 0 for obtaining nominal data like frequency, percentage, and proportion. Kung sa norm, i-reference test, ang madaling item ay mahina kasi di niya maipakita ang kaibahan ng estudyante. Sa criterion reference test, ang madaling item ay mahalaga kasi pinapakita nito na naabot ng mga estudyante ang target na kasanayan or mastery. In conclusion, Chapter 9 reminds us that improving classroom based assessment test is an essential part of the teaching and learning process. Through both judgmental and empirical approaches, teachers can ensure the test items are clear, fair, and truly measures the intended learning outcomes. As future educators, it is our responsibility to make our assessments valid, reliable, and meaningful so that test results do not simply measure performance but also guide us in improving instruction. Thank you, and I will now turn over the next part of the report to my groupmate.
So, hello everyone. My name is Caroline Humalon Mayol, a BSS Science second year. So, this will be the continuation of the report of Miss Callis. So, so we have here the first part of the concept report, which is the difficulty index. for an item. So first is what is difficulty index? So the difficulty index represented by the variable p indicates how difficult the item is. It is calculated as the proportion of students who answered the item correctly. So we have the formula, which is P equals R divided by T. So the P is the difficulty index. The R is the total number of students who answered the item correctly or right. Okay. Next, we have the T. T is the total number of students who answered the item. So, in simpler terms, if you want to find out how difficult a question is, um, you divide the number of students who got it right by the total number of students who attempted the questions. The resulting value, which is the P, is the difficulty index. The higher the P means the question was easier, and as more students answer it correctly. So the next part is we have here the illustrative example. So the image provides two examples, item 1 and item 2. The illustrations shows how the difficulty index, which is the p-value, is calculated and interpreted. It also offers insights based on normative reference and criterion reference settings or testings rather. So first we have the item 1. The scenario, which is in a class of 45 students, 30 answered item 1 correctly. So we have the calculations of P equals 30 over 45 equals 0.67. So in this formula, the interpretation of item 1 has a P value of 0.67. So this value means that 67 of the students got the right the right answers while 33% missed it. So that's for item 1. The item 2, we have the scenario that in the same class, only 10 students answered item 2 correctly. So in calculations, we have the p-value equals 10 over 45, which answered 0.22. So from these calculations, we have the interpretations of item 2 that the p-value of 0.22, only 22% of the students got the item right, while 78% missed it. So from the normative reference test perspective, so its analysis is that the item 2 is considered much more difficult than item 1 because less than a fourth of the class could answer it correctly. So a normative reference test compared to a student's performance against the performance of other students. So since a small percentage answered item 2 correctly, it's deemed difficult related to the group. That's for the normative reference test perspective. While on the other hand, we have the criterion reference test perspective, which we have the analysis of the item. So the class shows much better performance than item 1. I mean, yes, the item 1 than item 2, indicating that many students have not yet mastered the concept tested in item 2. So this explains that the criterion reference test measures a student's performance against a set of predetermined criteria or learning objectives. The low success rate on item 2 suggests that many students have not met the criteria for the specific item. So to understand these illustrative examples, so the item 1 is relatively easy for the class while item 2 is challenging. So the analysis highlights how difficult indicates can be used to evaluate test items and understand students' performance relative to each other's to a specific learning objectives. So that's how the illustrative samples explain. Now we have the next part, the discrimination index. So, what is a discrimination index? So, this definition is that the discrimination index, which is the D capital, measures how well a test questions differentiates between high performance and low performing students. So, in other words, a good test questions should be answered correctly more often by students who understand the material well, which is the high performing, and answered incorrectly more often by students who do not understand the material as well, which is referred to the low performing. So the discrimination index tells you how effective this question as it doing this. So we have the next part, which is we have three types of discriminating items. First is we have the positively discriminating item. So what is a positively discriminating items? So this means that a test items where the proportion of high scoring group answering correctly is greater than the proportion of low scoring group answering correctly. So to understand this positively discriminating items. So this means that a question is considered positively discriminating if the students who generally performed well on a test are more likely to get that questions right compared to the students who generally performed poorly. This is desirable characteristics of test questions, so it is understandable for the positively discriminating test. Next is we have the negatively discriminating items. So this means that a test items where the proportions of the high scoring groups answering correctly is less than the proportion of a low scoring group answering correctly. To understand this concept is that once a question is negatively discriminating, if the students who generally perform poorly the on the test are more likely to get that questions right compared to the students who generally perform well. This is an undesirable characteristic, so it is undesirable characteristics for test questions as poorly written, confusing, or testing someone's unrelated to the intended material. So next is we have the non-discriminating. So this is will be the last part of the three parts of discriminating items. So we have the not discriminating items. So not discriminating items refers to the a test item where the proportions of the high scoring group answering correctly is equal to the proportion of the low scoring group answering correctly. So in simpler terms, a question is considered not discriminating if high performing and low performing students are equally likely to answer it correctly. Thus suggests this question doesn't effectively differentiate between students with good or poor performing understanding. So, that's the part of the discriminating items. Okay, so now let's break down to the formula for calculating the discrimination index D from this concept. So we have the formula, we have the D equals R U over TU minus R I over TI. So what does this formula means? So D represents the item discrimination index. RU is the number of students in the upper, which is the high scoring group who got the items correct. The TU, which is the total number of students in the upper high scoring group. The R the RI refers to the number of students in the lower, which is the low scoring group who got the items correct. And last is we have the TI, which is the total number of students in the lower or low scoring group. So the calculate so to calculate the proportion of correct answers in a high scoring group, which is the RU over TU, is we have the to calculate the proportion of the correct answer is the scoring group, which is the RI and TI. We need to subtract the proportion for the low scoring group for the proportion of the high scoring group. So the result would be D is the discriminating index. So next is we have the another formula. So next is we have the another formula, which is the D equals RU minus RI over T. So where we all know that the D represents the discrimination items or the item discrimination index. The RU is the number of students in the upper high scoring group who got the items correct. RU, which is the number of students in the lower or low scoring group who got the items correct, and T is the number of students in either the upper or the lower group. So to find the difference between the number of correct answers in the high scoring group and the number of correct answers in the low scoring group, which is the RU minus RI. We need to divide that difference by the number of students in one of the group, assuming both groups have the same sizes. So the key differences from this previous formula is that this formula is simplified and assumes that the number of students of the upper group, which is the TU, is equal to the number of students in the lower group, which is the TI. So if the group sizes are different, this formula will not give an accurate discrimination index. So from the previous formula, it was calculated the proportions of correct answers within each group before subtracting. So this formula subtracts the raw number of correct answers and then divide by the group sizes. So when we'll be using this formula, so this formula will be using is suitable when you have to divide your students into two equal sizes group, which is the high scoring and the low scoring group, and want a quick estimate of the discrimination index. So if your groups have different sizes, it's better to use the previous formula, which is the D equals RU over Tu minus Ri over Ti. So yeah, and now let's have this another formula of the discrimination index represented. So we have the formula D equals Pu minus Pi. So we all know that D again represent a item discrimination index. The Pu, which is the P value, which is the difficulty index for the upper high scoring group, and we have the pi, which is also represented as p-value in the difficulty index for the lower group or low scoring group. So how do we calculate this formula? So in order to calculate the formula, we must calculate the p-value, which is the difficulty index for the high scoring group. This is the proportion of students in the high scoring group who answer the items correctly. We have the PU equals RU over TU. So, in order to calculate the P value, which is difficulty index for the low scoring group, this is a proportion of students in the low scoring group who answer the items correctly. This refers to the PI equals Ri over Ti. We must subtract the p-value of the low-scoring group from the p-value of the high-scoring group. So why do we need to subtract this kind of formula of the p-value? So this formula is essentially a more concise way of expressing the original discrimination index formula. So that index formula that is mentioned is the D equals RU over TU minus RI to the TI. So since PU is just a shorthand for RU over TU and PI is a shorthand for RI and TI, we must substituting those values into the original formula that will give us the simplified formula, which is the D equals PU and PI. So if you are confused to how we gonna use this formula, so this is a straightforward way to calculate the discriminating index if you've already calculated the p-values. Difficulty index for the high scoring and low scoring group. And now as we have the total number of students answering the items and the total number of students answering the right items or right correctly. So these variables are fundamental for calculating items difficulty, which is the p-value, which is used when the discriminating index. However, it's important to reminder that to calculate the discrimination index, you need to divide your students into high scoring group and a low scoring group and calculate T and R separately for each other. So that's the end of my part and my co members will continue this report.
Good day, everyone. So, my name is John Mark L. Montijo from the BSUD Sciences, and I am the last reporter of Chapter 9, Improving a Classroom Based Assessment Test. And I am going to continue the report of Ms. Mayol, which is the Discrimination Index. So, to obtain the proportions of the upper and lower groups responding to the item correctly, the teacher follows these steps. First, score the test papers using a key to correction to obtain the total scores of the students. The maximum score is the total number of objective items. Second, order the test papers from the highest to the lowest score. Third, split the test papers into halves, high group and the low group. For a class of 50 or less students, do a 50-50 split. Take the upper half as the high group and the lower group a half as the lower group. So if we have a 50 students, we should split it into 25 high group and the 25 into a low group. And for a big group of 100 or so, take the upper 25 to 27% and the lower 25 to 27%. That's the same. Maintain equal numbers of test papers for upper and lower groups. The fourth step is to obtain the p-value for the upper group and the p-value for the lower group. So we have here the formulas of each group, the upper and the lower group. So if we give an example, so if 50 students taking the exams or a test and we split their papers into halves, we have 25 students in each group. So we have P equals to RU over TU. So RU means the students answering the item right, and TU is the number of students answering the item. So 20 students answering the item 1 correctly divided by 25 students answering the item is equals to 0.8. That's the p-value of the upper group. Next is the p-value of the lower group. So p equals RL over TL. So that's the same with the upper group. So RL is the is the number of students answering the item right, and the TL is the number of students answering the item. So if 11 students answering the item 1 correctly divided by 25 students answering the item 1 is equals to 0.44. And that's the p-value of the lower groups. Now, we already obtained the p-values of each group. Let's now proceed to the last step. So, get the discrimination index by getting the differences between the p-values. So, we have here the formula on getting the discrimination index. So, we have three formulas in getting the discrimination index that Miss Mayol already discussed. So, D equals to RU minus RL over T. So, RU means a number of the upper group getting the item correct minus the RL. RL means a number of students get of the lower group getting the item correct. And the T means the number of students either group. So, ikaw bahala kung anong ilalagay mong kung dito, groups if kung gusto mo upper or lower. So, depende na sa'yo yan. So, ginamit pa rin natin yung formula natin dito, 20. So, 20 students of the upper group answered the item 1 correct and minus 11 students of the lower group answered the item 1 correct over 25 students of either group is equals to 0.36. So that's the discrimination index, both p-values. So for purposes of evaluating discriminating power of items of FAM 2011 offers the guidelines proposed by Abel and Frisbee 1991 shown in the table 9.2. The teachers can be guided on how to select the satisfactory items and what to do to improve the rest. So this is the table 9.2, guidelines for evaluating the discriminating efficiency of items. So if the discrimination index is 0.40 and above, that is a very good items. So if 0.30 to 0.39 naman, that is reasonably good items but possibly subject to improvement. So, kailangan i-improve yung item. And if 0.20 to 0.29 naman, that's a marginal items usually needing improvement. And 0.19 and below, that's poor items to be rejected or to improve by revision. So, kailangan talaga na i-revise or improve yung item kapag 0.19 or below na ito. The items with negative discrimination indices, although significantly high, are subject right away revision if not deletion. With multiple choice item, negative D is a forensic evidence of errors in item writing. It suggests the possibility of wrong key. More knowledgeable students selected a destructor which is the correct answer but is not the keyed option. So wrong key means students choose the correct answer pero nagduha-duha sila. Alam nila na yun na yung pinili nilang sagot na tama, nag-iba yung isipan nila nga baka mali yun, ganyan. So, next is unclear problem in the stem leading to more than one correct answer. Is the ambiguous destructors leading to the more informed students that be divided in choosing the attractive options. So, ambiguous destructors means that there are two choices, but either it's only one best answer. So, ang ambiguous destructor ang tamang sagot, pero isa lang yung dapat na sagot. So, dito, masyadong convincing yung bawat choices. The last is implausible keyed option, which more informed students will not choose. So, implausible keyed option means that these options are obviously wrong options, and students that are knowledgeable enough, they will not choose it as their answer. So, implausive keyed option ay yung mga choices na masyadong halata na hindi hindi yun yung tamang sagot. So, yan yung implausive keyed option. So, this structure analysis. So, another empirical procedure to discover areas for item improvement. It utilizes an analysis of the distribution of responses across the distractor. So, it can detect differences in how the more able students respond to the structures in a multiple choice item compared to how less able ones do it. So, before we discuss about the structural analysis, let us define what is distractors. So, ang distractors ay yung mga maling sagot na nasa multiple choice question. Kagaya ng if the plants are dying for lack of rain, you should, yun yung question. Options ay yung A. Water them, B. Ask a florist advice, or C. Put fertilizer around them. So, merong tatlong option. So, yung tamang sagot is letter A, water them. At yung destructors ay yung letter C at saka yung letter B na ask for florist advice at D, put fertilizer around them. So, maaaring sagot yung C at saka D, pero mali yon. Ay yung tamang sagot ay yung letter A na water them. Because if plants are dying for lack of rain, you should water them. So, yung destructor analysis naman is, ito yung nag-evaluate ng effectiveness ng mga maling options o natawag nating disruptors. And this process helps improve test item quality by identifying poorly constructed disruptors that either too obvious or too implausive. So, yung destructor analysis is ito yung nag-evaluate kung gaano ka epektibo yung mga distractors sa questions. So, kung hindi masyadong effective yung distractors, ay kailangan i-revise or i-improve pa yung mga distractors para maging effectives. So to illustrate this process, consider the frequency distribution of the responses of the upper group and the lower group across the alternatives for two items. Separate counts are done for the upper and lower group, who choose A, B, C, and D. The data is organized in the structure analysis table. Table 9.3, the structural analysis table. We have here two items. So, example, we have in item 1, the difficulty index is 0.38 and the discrimination index is 0.35, and it is split into two groups, the upper and lower groups, and we have here the four alternatives, the A, B, C, and D. So, example, in the upper group, the keyed option in the alternatives is the letter B. So in the upper group, majority of the students choose the best answer or the correct answer, letter B. So, ibig sabihin, hindi effective yung destructor kasi yung destructor ay yung letter A, C, at saka yung D. So, yung upper groups, napagtanto nila na yung tamang sagot ay yung letter B. Pero dito naman sa lower group, effective yung destructors kasi walang nakasagot sa tamang letra na yung letter B. Dalawa yung nakasagot sa letter A na disruptors at saka 12 naman yung nakasagot sa letter C na disruptors din at saka 6 yung nakasagot sa letter D na disruptors. So, mas epektibo yung disruptors sa lower groups kasi walang may nakasagot sa tama. So, um, That's the same with the item 2 that we have here. That if the item 2 have 0.45 and the discrimination index is 0.50, and it's split into two groups, the upper and lower groups, and if the key answer or the correct answer is the letter C, so we can say that the upper group is more knowledgeable enough to choose the right answer. So the destructors in the upper group are not effective because they choose the right answer. But in the lower group, the destructors here are more effective, especially in the letter B, which has a 14 students choose the letter B as their answer, and only one student choose the letter C as their answer. So that's the destructor analysis table. So sensitivity to instruction index. Another empirical approach for reviewing test items is to infer how sensitive an item has been to instruction. This is referred to as sensitivity to instruction index or SI, and it signifies a change in students' performance as a result of instructions. The information is useful for criterion reference tests, which aim at determining if mastery learning has been attained after a designed or prescribed instructional period. Dito sa sensitivity to instruction index is dito nami-measure ng teacher yung kalaman ng bata habang sa pre-test at saka sa post-test. Kung sa pre-test, nagpa-test yung teacher tsaka yung nakuhang score ng bata ay mababa. And then, kapag nagpa-post-test siya, tumaas bigla yung score ng bata dahil ito sa learning. Kasi sa pre-test is dito nami-measure muna yung hanggang saan yung kaalaman ng bata ba. At saka pagkatapos ng pre-test, mag-discuss, ah, bibigyan ng kaalaman ng teacher yung mga bata about kung ano ito, kung ano yan. At saka kung magpa-post test siya at mataas yung scores ng mga bata, doon natin malalaman na epektibo ang sensitivity to instruction index kasi tumaas yung score ng bata kasi meron na siyang kalaman. Meron siyang natanggap na instruction or learning na galing sa kanyang teacher. Yun yung example. Basic question being addressed is a directional one. Example, if a student's performance better after instruction is given, in the context of item performance, SI will indicate if p-value obtained for the item in the post-test is greater than the p-value in the pre-test. Consider an item where is in a class of 40, 80% answered it correctly in the post-test while only 10% did it in the pre-test. So we have here the example and the formula on how to calculate the SI. So it's a p-value for the post-test is 80% or 0.80 while for the pre-test is 10% or 0.10, thus SI 0.70. Dito is na-solve na niya yung SI. Ito yung sensitivity to instruction or SI equals to P for post-test minus P for pre-test. So, yung post-test niya ay 80% or 0.80 may minus sa 0.10% sa pre-test. So, equals 0.70. So, ganyan lang kadali yung sensitivity to instruction or SI. So, similar to the interpretation, the higher the SI value is, the more sensitive is in the showing the change as a result of instruction. This item's statistics gives additional information regarding the efficiency and validity of the item. There could, however, be reasons if SI of a test item does not register a meaningful difference between post-test and pre-test, especially for a knowledge level item. It is possible that it was not taken at all during instruction, so the students did not have the chance to learn it, or they already know the item prior to instruction. The teacher should take note of these items for reviewing content coverage for the period. So, I think that's all for my report, and thank you for listening. Goodbye. Thank you.